Shown here are the reagents and tools needed to perform targeted amplification using polymerase chain reaction, or PCR. The primer sets you will use will depend on your target organism and will arrive dry and need to be rehydrated. Refer to the side of the tube for the volume of buffer to add to each tube. Add the necessary amount and figure flick or vortex to mix and let them sit for 10 minutes to fully rehydrate. Once hydrated, the primers will be at 10 millimolar working concentration. Primers store well at 4 degrees Celsius for several weeks or at negative 20 degrees for long-term storage. Avoid freeze-thaw cycles as this may result in primer degradation. You can aliquot the primers into separate tubes to avoid this cycling if you plan to use the primers over a long period of time and need to store them. PCR beads are pre-formulated and pre-dispensed freeze-dried PCR reagents. Each bead is concentrated for a 25 microliter volume reaction and includes all of the required reagents of a PCR reaction. These include the essential components of DNTPs, magnesium chloride, buffer, Taq polymerase, as well as other compounds designed to improve PCR robustness. They are completely stable at room temperature and have a long shelf life when kept in the storage bag and kept away from excess moisture. They are highly hygroscopic and must be kept well sealed to remain viable. The beads come in their own PCR tube and make mixing the reagents easy and reduces the amount of liquid transfer and wasted tubes. Be sure to label all PCR bead tubes with sample ID on the top and on the side. In addition, create a map of each sample's position in the thermocycler in case any of the labeling wears off. For each reaction, you will need 0.5 microliter of each primer at a 10 millimolar concentration. As well, you will need 1 microliter of DNA template and enough PCR-grade water to bring each reaction volume up to 25 microliters. Be sure to take the 1 microliter of DNA from the top or the supernatant of the liquid sample. To prepare a master mix of primers and water, do the math ahead of time by multiplying the number of samples by each volume of primer and water needed. It is best to mix all of the water and primers in a separate tube and dispense to beads. Vortex or finger flick the bead and reagents for 10 seconds. The bead may completely dissolve, but if it does not, do not worry, as the heat of the thermocycling will bring all reagents into solution. Spin down the PCR reaction in a mini centrifuge. Place in thermocycler. Remove from thermocycler when the program finishes. Place in refrigerator if not using right away. Prepare 1% gel by measuring 0.5 grams of agarose and 50 milliliters of TBE or TAE buffer. Mix these two reagents in an Erlenmeyer flask by swirling. Then place in microwave and heat for 30 seconds. Open door to visually check if the mixture is clear. If not, continue heating for 10-second increments until the mixture is completely clear with no agarose in suspension. But always wear protective gloves or mitts to handle the flask as it will be extremely hot. Wait for the mixture to cool to approximately 55 degrees Celsius. Meanwhile, assemble the gel rig and combs. When the solution has cooled, pour it into the gel rig. While the gel is hardening, prepare the loading die and samples on a piece of parafilm. For each sample and control, pipette 2 microliters of 6x loading dye onto parafilm. Then pipette 10 microliters of sample onto each dot of dye and mix up and down in the pipette tip. When gel is set, load samples and dye into the individual wells. Then load a ladder or standard into a separate well. Make a map of your gel so that you know what sample is in each well. Connect the gel rig to the power supply and run between 95 and 105 volts. However, the voltage may vary depending on the size of the gel rig. To verify that a current is flowing, look for bubbling at the negative and positive electrodes. Be sure your gel is oriented for DNA to migrate toward the positive electrode. When finished, turn off the power supply and remove gel. Place gel in staining bath. Time will depend on type of stain used. To clean up the remaining PCR product, use Exozap It. To maximize its longevity, use an alternate protocol of 1 microliter of Exozap It for every 10 microliters of PCR product. Therefore, if you have 15 microliters of PCR product, add 1.5 microliters of Exozap It. Be sure to keep Exozap on ice the entire time that you are using it. After mixing by vortex or flicking, spin down in a mini centrifuge and place in thermocycler.